You're listening to Sasha Talks Tech, a podcast about technology, innovation, and leadership. My name is Sasha Prokhorova. I'm an engineer and a language analyst. This is episode number 3, and our guest today will tell us all about breaking into the data science career, about programming in R, and why it's more preferable than Python in certain cases. He will teach us all about writing a proper data science resume, and he will also tell us all about data science bootcamps and how they're different from the master's degree. And we're going to talk about pros and cons of two approaches. So stay tuned. Hi, how are you, Carlos? Thank you for joining. So today we're going to talk about applications of R programming language in data science and why R is so important.
Awesome. Yeah, I love R, so very excited for this one.
I know. I heard it has very strong statistical capabilities. As for me personally, I'm more of a Python user, and this is why I'm excited to have this conversation today, just because I want to learn more about R's capabilities. I heard it's an absolute champ in data visualization, right?
Yeah, so I think we can start off with R versus Python. That works for me. I'm not super anti-Python, but what I've found is that for individuals, like just if you're just by yourself at a computer and especially people who use Excel, like if you use Excel all the time, the transition from Excel to R is like pretty smooth. There's a lot of like really cool courses that let you do that. And then just in general with R Shiny, R Markdown, there's just a lot of ways for like individuals to make like really big impacts by themselves. And what I've noticed with Python is while there is like Python Dash and stuff like that, it's more so like Python works really well in like teams. So what I've done in like some of my product management is we'll have data scientists use Python, put that in like a Docker container, and then have APIs that go back and forth with the Python. So Python is like one very strong, very fast, isolated component, and it's mixed with everything else. So I like Python, but for individuals, I think R is like super useful, especially Shiny, which is still new. Shiny didn't come out till 2012, so it's not even 10 years old yet.
Oh, I remember. Yeah, R is one of the packages. Shiny is one of the packages used in R. And Mehta had a course on it on the last Data Science Go conference, right?
Yeah, so I was going to say, yeah, Matt Dancho has a ton of courses. If you use Excel all day and you need to stop, Matt Dancho. If you're trying to just get good at R, Matt Dancho's courses, Business Science University. We actually put people at Guidehouse through a few of his courses. We're actually developing an advanced R and production Shiny course that I lead, based on some of the things we've learned through his courses also, and just my own experience in R. So R is huge. I think it's growing really fast. I know its rankings aren't the best, so whatever the TIOB rankings are, but I love it.
Yeah, I heard it's a very powerful tool, and there are so many packages that exist nowadays. And also, our support community out there is pretty strong, right?
Yeah, so CRAN has, I think, like 15,000 packages. The big thing is, I always hate doing this because people like love Python, and I get why people love Python. It's easy to read. It's pretty fast. There's a lot of benefits. I just think that when you get into actual statistics, like people in Python, they're not always coming out with like statistical groups and like academics making these packages that are going on a PyPy or whatever. In R, you see a lot of packages get developed because a university or a group of statisticians or part of a journal submission, they'll use R. So biostatistics is a huge field that uses R. They actually have a biocran for just their biostatistics stuff. So I think if you're like really, really focused on like the correctness of the math, R is like the way to go. And I know scikit-learn's always adding new algorithms and stuff like that, but you can even Google this. This is not just me. Like, you look at how Python implements certain algorithms and you realize like, oh, this actually like isn't technically correct. It's using like these weird shortcuts, or it's made by a computer scientist, not a statistician. For everybody's everyday average work, they both work. I'm just noting because I think that's something people don't realize is that R has a huge statistical backing in terms of like, again, academics, universities, and stuff like that.
Would you think R tends to have a steeper learning curve in comparison to Python?
Learning curve is a bit subjective. I mean, you learn by doing, so it really depends on what you're doing. There's a really great book for Python called Automate the Boring Stuff. It's probably one of the most famous Python books out. I have a PDF of it personally, and it just goes through like how you do all the command line automations for Python. And I've seen some really cool stuff in the command line all run in Python. So
Yeah,
again, I think
I actually downloaded this book myself because I heard a lot of good things about it and I was just curious and I went to check it out. I just started reading it and so far it looks really promising.
yeah, I highly recommend it. You can find all the books in the world for free if you know where to look. I'm not gonna get in trouble and tell you where, but yeah. What was I saying? Yeah, I mean, I think again, even if you look at that book, though, it tells you about Python and Linux, and it just, I think Python leads you down a path of like you might need to know other things too, and R is like pretty good about you only need to know R. So Shiny, if people don't know, Shiny is a package that came out in 2012. And what it does is it's a wrapper for JavaScript and HTML that you can do inside R. So all kinds of web applications, even like GitHub IO, like websites with other packages like Blogdown, you can use only R, and you can do like websites and web applications. So it's like a single language tool. And I think Python, I mean, Python has Dash, I know I keep saying that, but it's not as easy. I mean, it's really not. I've seen Dash applications, and you're like, okay, I got to figure out the exact pixel width of this box. It's like super in depth. Not so. I mean, learning curve. Python's easy to read. I think it's easier to learn the letters in Python, but sometimes you can't really make sentences in Python. Sometimes. But yeah, I mean, I'm not a super Python expert, so I don't want to talk too much about Python.
Yeah, of course, of course. So where else, what other spheres is there are used in? Would you say it's fintech or IT or maybe even in the government?
Yeah, so I know in government they're shifting a really hard away from like enterprise purchasing stuff. So like SPSS, data, SaaS, you have to pay tens of thousands of dollars per person to have this stuff, and it's super expensive. And I know people might have heard of like vendor lock and like vendor lock-in, mostly in context of cloud computing, but it happens with like all kinds of software. I mean, even like Microsoft Outlook, right? Like now there's Gmail Suite and G Suite, but people are still stuck in Microsoft world. So vendor lock's real. And I think people who are using SaaS and Stata and SPSS, they naturally transition more into an open source tool that's free and robust. And what they'll do is they'll go to R mostly, because the statistics are so much easier. You don't have to do things like import scikit-learn and import NumPy and all this stuff like that. It just works out of base. And a lot of people, especially in government, live in base. Like there are government clients that they have their own package repos, and they only use like specific versions of everything. So I think R is pretty nice for that. And RStudio, I mean, I think none of this would be true without RStudio. Like they've been the forefront of like developing R and tidyverse. So I think maybe Python's missing that in some sense, that they don't have like this giant collective of people who are just burning money in a centralized team to like make something better. And I know there's Anaconda and like PyCharm. There's like really a lot of IDEs, but it's not the same.
Yeah, of course. And I remember taking a look at the RStudio the other day. It seems like a pretty strong learning resource for the R.
Yeah, there's cheat sheets. RStudio has a gallery, so if you go to like RStudio gallery, there's Shiny widgets, and there's like you can just learn so much stuff all from the same place, off cheat sheets, resources, videos. I was just at RStudio conference last month at the end of January in San Francisco, where I was supposed to see you. Didn't get a chance to see you. I know you were in Europe. But that conference was insane. I mean, you just learn so much so quickly.
Yeah, I know. I wanted to attend that too, but unfortunately I was out of the country. I was just traveling.
Where did you go? You didn't even tell me where you went.
Oh, I went to Paris, Warsaw, Prague, Berlin, Stockholm, Riga, and Smolensk.
Holy cow. Where did you how long were you out of the country?
3 months.
Oh man, I'm so jealous.
Yeah, I had an amazing time, and I was going to conferences and events in tech. And I also recommend some of the resources if you're trying to break into tech and meet people So yeah, and if you're trying to spend time productively, there's so many events, and the European tech is booming right now. I went to so many amazing events, and I met a lot of interesting people. And I always made sure I attended at least one or possibly even two events per city I went to, and it was just such an amazing opportunity, such an
Was a
amazing
lot of it
learning.
in English?
All of it was in English.
Oh, wow. That's cool.
Yeah,
Yeah,
because
I guess
I do speak Russian as a first language, but when I travel, I only speak English.
that makes sense. You don't want to end up in like, I don't know, some former Soviet Union place and then you speak Russian and someone gets mad at you. That's crazy.
Actually, it's funny. I did travel to some former Soviet Union places. It was Riga and Latvia and Russia. But yeah, like I mostly used English in Latvia, but I use Russian in Russia.
Oh, your question also, we got so distracted. FineTech. So at the RCity conference, there was this really cool talk by T-Mobile. There's some people from T-Mobile, and they use R in production, and they have like millions and millions and millions of records that they're doing like all kinds of like APIs, and they're hitting these APIs like a million times a day, like hundreds of thousands of times a second for depending on some things. It's like insane what they do. And they actually have a book that two people, I think Jacqueline Norris, I think is one of their names. It's very cute. They're like married, and they both of them work at T-Mobile in different fields. So they have this book called like Building Your Career in Data Science. You can Google that exact title and definitely buy the book. So yeah, they're super nice, and they're talking all about their work at T-Mobile and how they use R. There are some stuff things that R people in FineTech do. I know FINRA, which is this giant. I think they do like all of the stock market like checks, so like all like the compliance and insider trading stuff or something like that. They work with like the Securities and Exchange Commission. They have like billions and billions of like rows of data they're doing analysis on like constantly, like almost real time. And they have everything. I mean, they're using Spark, they're using like Azure, AWS, Hadoop. I don't know why they're using all these technologies, but they have a giant system and they're always using some kind of technology somewhere. And they have R and Python and Scala and like, I think they're even using Julia somewhere, which is interesting. So, I mean, yeah, I mean, I would recommend like anyone trying to learn one at first and get pretty good at one, but you probably should get familiar with both. Like it's not an either or.
Oh, okay. Because yeah, I heard a lot of dichotomy in the industry. So do we need to know both R and Python, or would just one tool be enough?
Get really, really good at one and then get okay at the second one.
Oh yeah. So once you master one discipline, then you're allowed to branch out and try new things.
Yeah. And I mean, I know some people maybe they don't work that way. They like to learn two things at once. So it's like, okay, let me learn 4 loops in R, let me learn 4 loops in Python, let me learn like APIs in R, let me learn APIs in Python. Like I understand if you want to do it that way. I personally my brain doesn't work that way. But I mean, I just say like as long as you're learning like every day, like just keep learning and don't worry because the competition is not learning every day. So all you have to do is just like learn like 3 things a day for like 2 years and you'll just be like so insanely good that you'll just have stupid money. Like
Oh yeah, of course. I completely agree. I constantly have to remind myself not to compare myself with other people in tech because there would always be someone who
Yep.
is so much more advanced, who has so much more experience, and who had done so much more. And I have to constantly remind myself that everyone has their own journey and their own learning path. And
Yeah.
I read the other day that if you spend at least an hour per day for a year learning new skill, in 1 year you will become an expert in this field. And for me, it's just enough to keep going and keep learning without worrying about what other people in technology are doing.
Yeah, so 2 things there. I mean, 100% agree. I'm doing this huge deployment right now for one of the products I'm managing, and it's like we're onto the client servers. We're using Docker. One of our Docker containers uses Python. One of them is like a PHP Laravel thing, so it's like all the web application stuff. There's no SQL servers. There's APIs connecting everything, and it is just not working. Like the Docker composition is just not working. Nothing's spinning up correctly, and I'm just out of my element. So I'm just like, well, I just admit that this is not my expertise and go find someone who knows Linux stuff and go find someone who knows like containerized deployment stuff. And it's totally okay, because one of these days they're going to ask me about our packages or their Shiny app's not working, and that's totally okay.
Of course, it's all
So
about collaboration nowadays, because it's impossible to be an expert in each and every field. And it's very important to know when to ask for help.
I think something too is I do a lot of resume reviews for free, so you can feel free to have people send me their resumes. I do a ton of these for free. Ideally, U.S. citizens open to positions at Guidehouse, but you don't have to be. I'll still review it. And I have articles on my LinkedIn too for people who want to know about like why their data science resume is bad, because I've only seen one out of like the last 40 something that I remember that was like almost presentable. So people are making tons of mistakes on their resumes, and I think one of the biggest ones is they're trying to be everything, which means they can't be hired. Like if I see your skill section and it is like C, NoSQL, Julia, MATLAB, SAS, R, SQL, PostgreSQL, Python, and then you have a bunch of packages like Beautiful Soup and like Shiny, ggplot2. Like if you just list like 50 technologies, the only thing I can do is look at your experience section, notice that you're still a fresher, like right out of school, and say, oh, you don't know any of these. You just are aware of these things.
Yeah,
so
you're
that
just
you're
aware
not
that
good at
things
any
exist.
of them. Yeah, so you can't be good at any of them. So it's like this paradox of like, well, you have exposure to all these things, but you need to be an expert to get hired, because it's all about specializing. So I do this every single resume. Well, 39 out of 40, whatever percent that is. And I've done a few hundred at this point. But it's
So
like,
basically, would you say sometimes less is more?
Well, less is also easier to read. Like there's so many resumes where I'll read it and I'm just like, this is so boring. Like I don't want to read 50 skills in a row. I don't want to read 50 technologies in a giant bullet point. Like I don't want to read like there's a list of garbage. And then I go to their experience section, and even then there's no story. It's just like helped profit by using Python. I'm like, this is not a bullet point. Like there's nothing here for like I can't you're trying, it's a sales thing. Your resume is a sales document.
So it has to showcase accomplishment. It needs to have some numeric criteria to help the person who is reading your resume evaluate. Yeah.
Ideally, quantified business impacts, like, use Python to automate one of our audit processes, reducing from like an 8-hour workflow to a 50-minute workflow. That's like a good example, I guess. Even then, it should probably have a little more of just like why it's worth doing, like why, like what does that actually open the person up to do? But it's just narrative. Like your resume is meant to be a narrative of what you've done, and I highly doubt anybody's done nothing. Like even these resumes that I see where I'm like, this is bad. This person's not going to get a job. I talk to them or I message them or I tell them this stuff, and they send me the updated version, and it's like, oh, you like traveled the world to get like an education, and you've been doing analysis not in R and Python but in Excel or something else since like 2013, and you have cool stories of like major impacts you've done, but you just don't think it's relevant because it's not techie enough, or you just didn't put it because it's old, or you just didn't put it because you didn't think anyone was interested in it. But like stories are like so important. And remember Carrie Twigg from Data Science Go?
Absolutely. She was one of my favorite speakers.
Yeah.
My main takeaway from her talk was that it's okay to be imperfect, and it's also okay to let people see it.
Yeah. I think I tried to like not block that out on my talk. I'm like, no, I gotta be perfect. I don't know why I reacted that way. But my favorite part of her talk was just like the importance of stories, and she had these story templates. And man, I should actually pull up some of these story templates. It's like when people ask you what you do, like it's okay to say like to like make up whatever you want, like you can say like, even if you're like, oh, I work at a restaurant as a waiter. You don't have to say that. You should if it's true, but you can also say like, oh, I'm studying Python at night because I'm trying to break into like customer segmentation and marketing analytics. Like your goal can be your story, as long as you're actually going for that goal. Kind of like, don't just make up goals. Like my goal is to be a billionaire. You got to do something to get that goal.
Of course. Yeah, and I can totally relate to that, because it's funny you should bring it up. I had waited tables for many, many years when I was still a college student, just because of the flexibility and steady income. It was something for me to fall back on so that I could study during the day. But it was just a money-making source. The goal for me has always been, my first goal was to become an engineer, and my recent goal is, like as of right now, is to eventually transition to machine learning, because I'm very interested in natural language processing. So yeah, and both.
Oh, NLP. We can talk about NLP like all day.
Yeah, because I'm so passionate about it, because it's like two of my degrees rolled into one. I did linguistics in Russia, and then I did the engineering in the United States. And just, I've been looking through the NLTK packages in Python, and this whole discipline is so fascinating to me.
Yeah, it is. I mean, I feel like data science didn't exist. I mean, obviously it did. I mean, I think people in the 70s and 80s were using expert systems in like physics with like millions of, data elements. So, I mean, big data has existed for 50 years and AI has existed for 50 years. But I think the new wave of like, oh, by the way, at this business, we accidentally create data, or we can tweak something and now we can like create data. I think that's relatively new. And R is turning 20 years old tomorrow. I found that on LinkedIn.
I thought
yeah.
it was younger than Python. I guess.
No. Well, I don't know, because R is a lot of S, and like S is old, but I don't know. I don't know much about the beginnings of it. But I just saw that on LinkedIn like today, and it's like R is turning 20 tomorrow, and I was like, oh, that's crazy. Wait, so what did you do that brought you into NLP, or makes you super into NLP?
Because nowadays the computer in general got so sophisticated. Back in the day, we didn't used to be able to, let's say, run sentiment analysis and semantic clustering or anything like that. It was just not available to us. But nowadays, it no longer takes the human to go through, let's say, thousands of reviews of a restaurant or a business of any kind. You can just run an algorithm to determine what's the reputation of a certain brand in a society, or what people are talking about this new restaurant that opened up, what would have taken hundreds of hours of human time back in the day. Nowadays takes, I don't know, maybe a minute, depending on the algorithm complexity. And this is what fascinates me about it. Computers are now capable of comprehending humans with all their emotional complexity.
Yeah, I don't do much sentiment analysis, but that is super cool. I mean, there's so much in NLP.
Can you do NLP in R?
I have done NLP in R. The product that I was just talking about uses Python for NLP. And that's just because the data scientist we had, he comes from an R background, so he just wanted to challenge himself and learn it in Python. And I'm not a very good person at saying no, so I'm like, okay, sure, you can do this extremely important project in a language you don't know that well.
Well, it's really good to challenge yourself. Within appropriate framework.
Yeah, and actually, that brings me back to the other thing I was going to say. When you said like learning 1 hour a day, I think people, I think there's a small, I don't want to say error, but a small warning that I would spit out to that. The best learning you can do is to work somewhere so that you're learning 8 hours a day and getting paid to learn. Like, that's the best situation.
That's the ideal case scenario.
Yeah, I just want to remind people of that, because sometimes people will be like, well, I have this job and it pays my bills, so I'll study at night. And it's like, oh, maybe if you actually like do the math on like the return of investment, maybe like taking a break from your job for 2 months and then studying for a month straight and then spending a month to get hired, that new job you get will pay so much more that you'll be able to pay off the debt you accrued by leaving your job for 2 months. Obviously, it's a very risky thing to do. I have done it, but it's extremely risky. I'm just noting that sometimes if you write it down math-wise, you would be shocked. Because, I mean, I grew my pay like 80% from switching into data science stuff. Seriously, like 80%.
Yeah, because I remember you have a master's degree in spatial economics, but you actually learned R by yourself on Coursera. How long did it take to master that skill?
Yeah, still not a master. I do put myself as like, I say like I'm the expert in it, because it like looks better when people are looking up people at our company, like, who knows R? That way I'll come up on top and help them. But yeah, I mean, my story there is I was teaching and I was like, this pays no money. So I was like, and I wanted to go to grad school because I just knew I wanted to get back into my field of economics and not do teaching. So I found that thing on Coursera. Took like 6 months. Coursera was pretty okay. I do recommend people I recommend you learn programming on the internet and not in grad school, because grad schools are very, very bad at teaching like
They're
computer
expensive
programming. They're super expensive. You're learning from people who aren't actually using the skill a lot. Like, that's not true for my grad school because I went to I was like kind of bougie, I guess. But even then I was like, oh, like these professors don't know R as well as I do, and I'm bad. Like, they're trying to teach us like WinBugs and OpenBugs and like SAS, and it's like, this is not the cutting edge stuff. Like, we should, like, everyone in this program should be learning R and Python super intensely. And now there's, North Carolina State University, they have the 1-year program, the Masters in Analytics. That's like the best analytics masters in like the world, I would say. We hire from them all the time. They get so many job offers. Every single graduate gets like so many job offers.
What do you think the faculty over there does differently from the other schools?
So they like started analytics master's degrees. Like, they had this idea like over a decade ago. They were like, oh, like analytics is different than like business, and analytics is different than like computer science. It's different from statistics. It's like the fusion of business and statistics and computer science. So they like actually from the ground up, and you can go on their website. They're seriously so good about just putting out all their numbers, like employment numbers, job offers per graduate numbers, ROI in terms of like, the time lost, the companies that are doing these offers. Anyway, so they like did from the ground up, and they're like, okay, you need to know like computing systems, you need to know databases, you need to know like AWS, Hadoop, you need to understand R and Python, you need to know web scraping, you need to know natural language processing, you need to know machine learning, you need to know like the actual math behind these things. They've just structured it so well. And it's only like 8 or 9 months, and they just have so many partners because they were like the first. I mean, people will come out of there with jobs in like the South, where it's like they don't like the money. It's like really not that good in the South. You have to be in like New York, DC, or San Francisco to get like a lot of stupid money. Boston too, but like they'll have people getting hired at like Home Depot, people getting hired at SAS, which is really interesting. Getting hired at major like retail companies, Walmart, Target, making like 6 figures. And these are people who, they have a bachelor's degree and they might have some business experience, but they didn't do analytics. They just got in because they were trying really hard and they taught themselves a little bit of R, and they really had a good application for like high effort, even if their talent wasn't all there. And they just like grinded it out. And now they're double, triple salary stuff. And you can all see this all online. They like have all their data out. They're really good about the transparency. So I didn't go to that school because I didn't want to do analytics specifically. I wanted to do economics, but that would have been my second choice for sure.
Wow, that makes me want to look into it.
I know. I'm serious.
The program is only 8 months.
It might be 10.
Still pretty
but
short.
It's not 2 years. It's 1 year.
Is it online or is it in person?
It's entirely in person, I think. I think they fully expect that you're going to show up there. To my knowledge, it's like you do 8 hours a day, like 9 to 5, and then you do group projects from like 6 to 9. Then you go to sleep and you wake up and you repeat. It's like
and do it again. So yeah, it's kind of like an intensive, all immersive program.
Yeah, and Lambda School too. Lambda School is the other one. They have some online stuff. Lambda School is working on a totally different model. They do, what is it? The CEO is really cool. If you just go on LinkedIn and go like Lambda School CEO, he like will let anybody connect with them. And what they do is you join and you don't pay them any money. And if you finish the program and you do get a job, and that job pays more than $50,000 a year, you give them some percentage of your income for 2 years, and it has a cap. So it's like, oh, I make no money, go to Lambda School, graduate, get an $80,000 job. That's more than 50 grand. I pay them like 15 grand a year out of my salary for 2 years, and then boom, I'm done. So you only pay the 30 grand tuition if you like get a job that pays money.
Wow.
And they have
I will make sure I include all those resources in the show notes, because I feel like there's so much important information that we're discovering today.
Yeah, Lambda's really cool. Obviously, I'm saying these things are cool having not done them, but I've seen people succeed in them. So I'm always like, oh, I mean, I know people who've done it and like done really well. So.
Yeah, you probably saw a curriculum or something like this that led you
Oh
to
yeah,
believe that they provide value.
yeah. And I mean, I did a lot of research on these because I considered doing them.
Of course, yeah. I was wondering, what's your opinion on those bootcamp programs that's been popping up all
Oh
around the
no,
country?
oh no, this is where I'm gonna get in so much trouble. I'm anti bootcamp. And it sounds weird to even say because Lambda School is technically a boot camp. There are boot camps that are super good. I think Flatiron School is good, based on knowing people who've gotten out and gotten really good jobs. I think there's one Springboard or something.
Oh, I heard of it.
There are a few that are good, but like this is what happens, right? Like you're going to be wanting to get into data science. You're going to find out that this place will take only $16,000 instead of $50,000 like a regular grad school, and then for $16,000 you can like show up at this place and you do 9 to 5, same thing, 9 to 5 and then 6 to 9 like group work, but it's not like, I don't know how to explain it. Like there's like pedagogy is like the theory of education, right?
Yep.
So there's like different theories of education, and some of these places are just like Coursera, but with other people next to you. And I'm not saying they're literally Coursera. Like you're not paying money to have a person show you Coursera. It's just like they're the equivalent of Coursera, just next to other people. And the people who come out, they don't actually know the programming. They just know like, I can copy paste this from Tidyverse. I can copy paste this from this GitHub. I have a billion GitHubs I can copy paste from. That's not programming. Like they just get really good at like copy pasting template code. And that's like the early stages stuff at like in programming. Like that's like level 1 in programming. It's like, oh, I can copy paste from Stack Overflow and edit and my problem's fixed. That's like level 1. Level 2 is like you can kind of create your own, like you can identify your problem and actually turn it into a reproducible example and post it on GitHub and get answers. That's like level 2. Level 3 is, more and more and more and more with like reprex and formal debugging. There's all those levels to it. But there's a lot of skills that like you have to vet these places. Like don't let them just like take your 16 grand or whatever and you don't even know their like graduation rates and like what kind of job offers people are getting. And the less transparent they are, the worse they are, just as a rule. Like you should go to the North Carolina State University website and look at their jobs report and be like, I expect every place that's trying to take my money puts out information this good. And you will notice that most places don't put out information that good.
Wow. Yeah, especially if they give certain promises, you expect them to deliver, especially for this kind of money.
And that's where Lambda School gets a lot of like its, validity, because they don't take your money until you reach their certain benchmark. And that's also why they're much more strict. Like not anybody can get into these places because they're actually putting financial risk there. These other boot camps, they'll take anybody's money. Even if you can't even type 50 words per minute, they'll let you try to become a computer programmer. So I think like the red flags are a lack of filter, taking everybody. Not a red flag, but just a notice. Like if they want your money before they like have made any commitments to you.
How badly they want your money.
Yeah.
Yeah,
but
because
again,
I agree. There should be some sort of a filter just to make sure that people with the right aptitude enter those boot camps, just people who can actually achieve certain results. Because if you admit somebody who is completely unprepared for the program, just tell them like, hey, go learn like the basics of like mathematical concepts and this and this and this. Those are the prerequisites that you must learn before you come back and try again, and then we'll see if we can admit you. To me, that would be a high quality of the boot camp rather than just admitting anyone.
Yeah, seriously. We covered a lot. Learning data science, resumes, people to follow on LinkedIn. I definitely, random things to do. Understand like negotiation and sales. Like it's super important. I think half of data science is convincing businesses to like invest in your idea. when you don't even know your idea that well. You're just like, oh, I think this could be automated. I'm not even sure what that actually looked like because I don't have the data to even do a template. But there's a lot of sales. I mean, a lot of sales in like data science to get the
Yeah,
data
you
to
need
approve the
you need to be
science.
able to sell your projects, and you need to be able to explain to the potential employer or superior whom you're reporting to why this is important and why this is going to save a lot of money to the organization.
I'm looking back at our list of topics. What else do we want to talk about? I wanted to talk about geography a bunch. I really did
Oh
want to talk about
yeah, because
geography.
I really loved your project on the geospatial mapping.
Oh yes, I have a lot of those. I think I showed you oh gosh, what was it? It was
It was
mapping black income.
black
Yeah,
households.
startup.
Yeah, yep.
Yeah, a startup friend of mine was trying to figure out like how she could, she's doing a lot of really cool stuff with like Born Brown, All Rights Reserved, really cool startup. Google their website, buy their stuff. Just like how to like uplift people who are like in disadvantaged communities and how to like support black owned businesses and all this stuff. And one of the things I talked about is like, part of this is like market segmentation and targeting and customer targeting and all this stuff. So what we did was we got like census data to identify like black households by wealth at the census tract level. And you can just like do a drop down search. It's like pick a state, pick a county. Here's that county on a map. Here's a census tract, color coded by like income, and you can like select different races, and you can kind of see like where do people who are a certain race and do have money, where do they live? And part of that, I mean, it sounds weird to say targeting, but like part of it is targeting. It's just like, oh, these people might really be interested in supporting this. Like they might be interested in purchasing these products if they agree with the mission. And that was an Arshani application, by the way, using Leaflet. So GAS, we can segue.
Yeah, so it's basically it helps you identify communities who need help the most. And this is basically one of those cases where we use data science to build a better world.
For sure. Data science for public good is like a whole thing. Citizen data scientists is a whole thing. People who are looking for experience, definitely, I would say don't just go on Kaggle and compete, because a lot of people go on Kaggle and they just like slap in like AutoML stuff and then they like get 8th place and they put on the resume. I would definitely say like focus on your GitHub, focus on narratives. So citizen data science stuff. Find cities with data portals. It's a huge thing. Data.gov if you're in the United States, huge thing. There's always free data. Do your own analysis, make your own charts, put it all together, make a GitHub pages, make a little website for yourself, all free on GitHub. You can literally type GitHub pages website and it'll come up. I have one. And then you can like post your stuff there. And just having like a portfolio that actually fits into your own career narrative and fits into your goals will just make it so much easier to get a job. Because the stuff I see is like, I know 50 skills. No, you really don't. I have minimal experience. Okay, that's okay. Everyone has minimal experience at some point. Here's my GitHub, and it's like super ugly and like impossible for a recruiter to read. And I can only read it because I know what all these things are. Like I know what IPYNB dot whatever stuff is. I know what a README is. I know that your README is bad. Like, you know what I mean? Like people are not making it easy.
It looks pretty good.
You don't have a GitHub? Is that what you said?
No, I do have a GitHub, but I mean, I remember looking through yours, and it looked really good. You had so many projects to show, and READMEs were all there. It seemed very organized.
Yeah, I think I say this a lot, but polish. I mean, I could talk of this forever. Like in all these resume reviews I do, I think if the number one thing is the lack of career narrative, I think the number two thing is lack of polish. Like your resume is a sales document, so the more polished it is, the more people will believe that you have attention to detail, the more they'll believe that you're organized, and the more they'll just believe what you wrote. Because I mean, it's like anyone can lie on their resume technically. So yeah, the more polish you have, the easier it is to believe. So polish means like if you link to your LinkedIn, you should not have your name like Bob Smith 1384-1E. Like that's so ugly. Like just go like Google how to change that. If you have a GitHub, should have your name. If you click that GitHub link, you should have pinned repositories that are not homework to blah blah blah. If you have a website, that website link better work. Like if it goes to a 404 page because you forgot to pay for your like Go GoDaddy hosting or whatever, that's going to look really sloppy. And these things happen. Like people will just like reuse really old resumes. They don't see the importance of the resume, and then they wonder why they don't get jobs. And it's because like, dude, I tried to explore. Like I tried to click the links you gave me. I tried to Google the company you worked for, and like nothing's coming up. So I mean, I think polish is like super important.
Yeah, it's important to understand that things like resume and LinkedIn and GitHub, it's a constant work in progress because, it takes a lot of time to create a resume. And once people are done with that first step of the process, then we're like, I'm done for a while now. But in my opinion, it couldn't be further from truth because you have to improve it constantly and regularly, either adding things or taking things away when appropriate. It just has to be your resume has to evolve and it needs to be happen dynamically.
Yeah, I think I said this in one of my LinkedIn articles. If your resume doesn't excite you, it's going to be boring to other recruiters. Like, I'm not even saying this to be vain. Like, I'm constantly looking over my resume because I don't want to like have a typo that slides by, or like I don't want to say something and that actually not even be correct. That like, oh, actually we didn't use that technology. I don't know why I wrote that. I was thinking of something else. So like I'm always trying to be accurate, clear, erase stuff that doesn't read well. So yeah, definitely get tons of advice on it too. Like again, I'll read anyone's resume, and my advice will always be the same 6 things because it's in an article. But yeah, let's switch to GIS. I know I'm looking at our list.
Yeah, let's talk about JS.
Okay, what do you know about GIS?
Not much, to be honest, and that's why I'm so excited to talk about it today.
Okay, cool. No, I just always want to know because I didn't know it existed until I went to like grad school, I think. And I was like, oh, I got these 2 classes waived because I did like the same undergrad as I did my master's. So they were like, oh, you know these 2 things, so change it out for 2 other things. So I was like, oh, geography sounds cool. And I found out that GIS is Geographic Information Systems, and it's like everything. Like, when I said physics and AI back in the 70s, this is like big data back in like the 30s somehow. Like these people were doing crazy stuff. I mean, like I'm talking about like they were like getting the whole world and like cutting it into pieces on paper and actually making different projections by hand. And they have like rulers and they're like measuring out latitudes and longitudes and then recording it on paper and then doing like these crazy calculations all by hand. Like people have been studying space and like spatial phenomenon forever. And I think spatial phenomenon and spatial correlations are some of the biggest gaps, I think, in data science right now. People know about residual analysis and they know about logistic regression and trees and neural networks and time series, but then they don't do spatial stuff. And it's like, hey, just like autocorrelation and time series data, you can have spatial correlations. Like think of like Walmart, right? Like where does Walmart put their stores? Like Walmart wants to put their stores where people will go buy them. And also they'll put their stores where they want to ship things from because Walmart, like Amazon, has to have like shipping now. So all their Walmarts are also distribution hubs. So now you have like these double problems of like, well, we want it to be accessible to people who drive there. And we also want it to be accessible for our people to drop off giant deliveries. And we also want it to be accessible for our drivers to, and USPS or whatever, to like use it to grab stuff and go deliver things. And now it's a huge spatial problem. Now it's like, it's a traveling salesman problem. Now it's like a heat map problem of knowing where people live. Now it's like a time series problem in terms of like your inventory. So, I mean, I think people are like really underestimating how many problems that they do and they solve are like fundamentally spatial in nature. So that's why I really like GIS.
Oh yeah, absolutely. In my opinion, geography doesn't get nearly as much love in data science as it deserves because we use it even more frequently than we know. Let's say even ride-sharing apps, they use certain algorithms to optimize the pathfinding for the rides. When they create a heat map of surges of like demand in the area during the time, it's all related to geography.
Yeah, I've never driven for Uber, but I know some people who've driven. And if you see the driver side of the app, it's really interesting. They'll have heat maps and they'll have like dollar signs on the heat maps. And it's like, oh, if you pick up from this region, it's like a bonus dollar or something. And
So
it's
it
like,
would,
oh, like how do you even create this? Like how do you even say not only the time series prediction of where people are going to order from, but also where can I encircle and how much added value can I put on this circle to make sure drivers go there? Like it's a price model, space model, time model.
there's so many variables that are involved in it. Because like, if it's something like airport, it makes sense. There will always be
Yep.
demand. But what if there's like a festival that's going on, or like some famous concert that's taking place? So the algorithm would have to know like what's going on in the city, like in the social life, what's going on with arts and the community, just to be
And
able
that
to make
and that
those
adds
predictions.
that adds a web scraping problem too. I mean, I think exactly what you just said. Like if you imagine if you're trying to get into the field, if you could put yourself in the shoes of a company or even make your own company, great start to your career, by the way. Work for startups. That's what I did. It was my first thing in data science. You can put yourselves in like a company's shoes and you can like think of one problem and you can like figure out all these other interconnected things of that problem. And you can do a little bit of spatial, have a map. You can do a little bit of time series, have like a plot of this, have a little bit of discussion. And if you can like show that you're a person who can think about the interconnectedness of these problems, you become so much more hireable. Um, and again, website, GitHub pages on your GitHub. Like there's so many opportunities. And that's why I'm not a big Kaggle fan, because Kaggle, I think, obviously everyone wants to win money, but sometimes Kaggle is like, it's so narrow. It's like, here's the data, here's a target variable, like use the rest of the data to predict this target variable. And it's like, okay, like a crazy like artificial neural network is going to win, obviously, like because you have no concern about interpretability and you don't care about the context. Maybe that's not true. I mean, it's been a while since I've been on Kaggle, so maybe they've done better in the last year or two. But
So basically, you're saying that Kaggle competitions can be lacking depth in certain cases?
yeah, I think some of them lack depth, and some of them don't. I mean, I think there's some really cool stuff in computer vision. I think for some fields, there's a lot of really cool stuff on Kaggle, especially image classification. But sometimes I see Kaggle stuff, and I'm like, oh, this competition's like not really that interesting. But yeah, GAS stuff to learn. There's all these JS packages. You don't have to learn any new software. Just learn a package. In R, there's Leaflet. In R, there's Plotly. Plotly has some app stuff. Leaflet's more into that. There's SF, which means simple features. I thought it meant shapefile, but it means simple features. In Python, I don't know. I think there's like PyGeos, GEOS. I don't know, actually. I've never done GIS in Python. But Python's fully
Yeah.
integrated into ArcGIS, which is the biggest company in GIS. ArcGIS is owned by Esri. They have Esri conference every year. They have like full Python integrations. And if you're open source, QGIS, known as Quantum GIS, is the free version of ArcGIS, and it also has Python integrations. I think that's where Python wins. You know, I had to take some bad stuff I said about Python back, because Python is really good about being integrated into other softwares.
Yeah, there are pros and cons about every tool. Like none of the tools will be completely perfect, no matter how much we love it and how often we use and rely on it. It's bound to have drawbacks somewhere. It's just the name of the game.
Oh man, book dump. Let me give you like a few books you got to read. I also just posted this on LinkedIn. I'm like, I gotta stop posting on LinkedIn.
I love reading your posts on LinkedIn. What are you talking about?
Thank you. I appreciate it. Swipe to Unlock. If you haven't read Swipe to Unlock, it's called Swipe to Unlock, a business primer or primer on business and technology or whatever. It's by these three guys. I think one's a product manager at Facebook. I think they all met at like Harvard or something. One of them's like a product manager at Microsoft. Anyway, super insanely good technologists, and they wrote this book. It's like 300 pages, and it's all just case studies of business and technology. And you got to follow them on LinkedIn too, because these guys are just insanely tech savvy in terms of like predicting what these giants are going to do. Like one of these guys was like, "Oh yeah, like I predict that Amazon's going to buy Lyft," and I was like, "Whoa, that's a huge prediction to make." Like, where are you
That is
coming
a
up with
huge
that?
prediction.
And he like laid it all out, and I was like, oh, Amazon should buy Lyft. Like, even if they weren't thinking about it, this guy has convinced me that they should, even though I don't want Amazon to get bigger.
Well, Amazon
Like,
bought Whole Foods out of all places. Nothing will
that
surprise me
was
after this.
Do you know why they bought Whole Foods? It's included in the book. I'll tell you. Sneak peek.
Ooh, spoiler.
So Walmart and Target, the major competitors of Amazon, right? They're doing really, really well in groceries because they already have infrastructure for refrigeration, and they have connections to all their like refrigerated trucks called reefers in the industry from freight brokerage. And they so they have all that infrastructure already. Amazon wants to sell people everything, not just like books. They started with books. They want to sell people clothes, they want to sell people toys, they want to sell people food. And it's really, really hard to sell spoilage, like, food that risk of spoilage, when you don't have like not only refrigerated trucks but also centralized areas to store this food.
You need to
So
have a vehicle for food distribution.
yeah, in the distribution centers. So they bought Whole Foods, and this isn't my idea, this is coming from the book, so I highly recommend buying this book. They bought Whole Foods because Whole Foods is boutique, which means that they have like high-end stuff, which also means they probably have extra space, because a lot of high-end places, to give you that high-end aesthetic, they'll have like wider lanes for like wider aisles to go down. They'll have like a more lean production system, so they don't hold a lot of stuff in the back. So Whole Foods was a great buy because it has good brand appeal, and there's tons of them in like important places in cities.
Especially San Francisco Whole Foods, it's like hipster headquarters.
Yep, hipster headquarters. That's a funny one. There was this place in Orlando where I went to undergrad, and they started after I left, called Lucky's, and they're closing now. But it was super hipster because what you would do is you go in and you would buy a beer and you would drink the beer, and they had special carts that would hold your beer as you like go do your grocery shopping. So people
like
would just go. Yeah, people would just go and like just drink up and down the aisles because they were like all licensed to be a bar. It's like a bar that's also has groceries. They're closing though, unfortunately. I never got to do that.
Oh, I would have loved that.
I know. I'm sure it's going to pop up everywhere now. But yeah, so Amazon bought Whole Foods because of the refrigeration distribution, according to this book. And the book is super cool. It covers the basics of the internet. It covers what APIs are. And it's all for people who don't know a lot of tech stuff. So it's like very made for MBAs, or even made for anyone who's ever worked for business at all. I think on my LinkedIn post I said, if you've ever been near a computer, read this book. And I felt that way at the time. 5-star book for sure.
Absolutely. I have to check it out now. I'm so intrigued.
And then second book I recommend, I'm not going to go into a lot of detail on, I haven't finished it yet, is The Unicorn Project. It's about how like business and like management can get in the way of technology, and like how technology needs things like, you need a lot of control to work in technology. You need to have admin rights to your computer. You need to have like access to development environments. You need to be able to control like a virtual machine. You need to like get feedback. Like imagine if you had to write code, right? And then you only got errors like a week after you submitted the code. And it's like, oh, I don't even know how I have no clue what this error means. Like, I don't know how to fix this. Like, you need your errors to be immediate. It's the same thing in startups. Like, you got to fail fast. But in here, it's like for one person on a single computer, you got to fail fast.
Fail fast and fail cheap.
Oh, yeah, cheap too. Yeah, very cheap. That's a good one.
Yeah, and like I would say, I would have to add, document your failure along the way as you go, so you can like always go back and reference it and probably analyze what went wrong, because failure is just as valuable for the learning as a success. I would say it's probably even more valuable than the success.
I think I'm gonna disagree on that one. I think sometimes we have a little meme about like the importance of failure. I don't really learn that much from my failures. It just tells me like, oh, this didn't work. But when I succeed in something after having failed, it like magnifies how much that success stays in my mind. So like I'm still learning from the success, but I get more like invested in the success when I failed a bunch of times. But, like I don't remember like all the errors I make, like I don't remember error codes in R or anything like that. So I'm not really learning from like that many errors.
That's fine. It is a good point, but actually I have like a little journal where I just write down notes of what I do on a daily basis in my professional life. And sometimes, like very often actually, I just write things that, oh, I tried that with that particular code and it didn't work. And then I tried this and it still didn't work. But then I tried something completely different and it did end up running. Yay.
You would
So,
love the main character of the book, The Unicorn Project, because the main character, she's older than us, but she's like the same way. She like keeps all these meticulous notes, and she's exactly like that. I think you come from a different background, though. Aren't you more from a software development background?
well, actually, my educational background is in electrical engineering.
Oh, engineering. Okay.
Yeah, but I developed, like, as I went through school, I developed all those new interests that I ended up doing research on. And that's why I deviated away from electrical engineering, because I got interested in data science and machine learning. So yeah, one thing led to another, and I ended up here.
Yeah, I think engineers think more structured than like social science people. So I think it makes sense that you approach problems that way. And you have like your meticulous notes. I'm not a note taker, unfortunately.
Well, I'm obsessed with note taking and organizing, and I still take notes by hand because it's one of my favorite things to do. I feel like for me personally, it keeps me awake and alert. It just keeps my brain alive.
Ugh, I need to start doing that. I've used OneNote, but OneNote stresses me out because I can't separate my OneNotes. It's like all one giant program.
The only time I take notes on the tablet is at the conferences where I take photos of the slides that the presenter
I know.
shows, so that I
How
can
come
take.
they never give you the slides at the end? Like it's
Yeah, at
so
the
hard to
end, but
find conference slides.
I know, but no, they give it to you at the end often. But I was like, I need them before so that I can jot some notes over them.
That's true. You probably want to print them out and like have like little spaces underneath each slide to write in.
Probably it could be. It's actually not a bad idea.
Okay, I know you have 10 minutes left. Yeah, what's the scoop? What have we not talked about?
Let's see. Oh, I want to talk about social media and R impact. Like, can R be used for social media analysis?
Yeah, I mean, anything with numbers, right? But more specifically, I'm gonna forget his name. This guy I know met on LinkedIn. I think he's in Indonesia, or he's Indonesian but lives in Singapore, Malaysia. Anyway, he does social media analytics, and he's always posting about like this thing that he's learning or this thing he's having problems with, or talking about like social media stuff. And he's all R. So I mean, in social media, you're always worried about ratios. So like your view to like ratio, your engagement percentages, your even LinkedIn terms, like your likes, your comments, add those together, divided by your views. Like, there's always metrics and KPIs that you make for engagement. Because ultimately, the whole profit from all the social media stuff is eyeballs at ads, and you can't put too many ads or you'll get less eyeballs. So,
It would be
I mean,
user segmentation just to show them the relevant information. It's not necessarily about the number of the eyeballs. It's about the number of eyeballs that care to see your content.
that's true. Quality eyeballs, I guess, is important, which is probably hard to measure. But yeah, I mean, A/B testing. I think anything you can break down in like the most statistic terms are a really good language for. So, market analysis, market segmentation, A/B testing. Oh man, there's a really good person to follow on LinkedIn for all the math stuff. Kevin Gray, I think that's his name. He's like he's been like an independent consultant, and he knows everything. He knows like SAS, SPSS, Jump, R. But he's always posting about like statistical stuff.
I have to make sure I check out his work because I love statistics and everything associated with it. It's just a fascinating topic to me.
Oh, this is where I get in so much trouble. I'm not that good at math. And I think this is where I get tripped up.
That's kind of unexpected.
I'm not that good at math. Like, I know facts. Like, I know that like margin of errors aren't additive, and I know like why, like what residuals are, and I can read like ACF and PCF plots, and I can kind of understand leverage. But you get into like some pretty interesting depth, like understanding why you choose certain loss functions, or understanding like why you assume certain distributions with your data, and how different models have different assumptions with these distributions. And I start really hitting my limit of understanding. Like, oh man, like there's so many keywords, there's so many buzzwords, like Gibbs sampling, Monte Carlo, like all these things are like, I know what they are,
Markov
kind of.
chains, yeah.
Yeah, MCMC. And I'm just like, oh man, like I know the idea, but I can't tell you the math. I can't prove anything of it. I can't even like, I'm not even sure I could do like OLS by hand anymore.
This is amazing. I feel like we're breaking so many stereotypes right now because data scientists are pictured to be like almost synonymous to mathematicians, but it cannot be. Yeah, it's obviously not entirely true now that I'm discovering.
Yeah, I mean, I think you got to know some fundamentals. Like you got to know, it's just like, you know, you got to know the concept, and you got to know enough of the concept to know what to Google. But outside of that, I mean, I said this earlier today too, because we're doing these like skill assessment things, and like we're assessing our own skills, and I'm always like, oh, okay, 1 is nothing, and like 5 is expert. Well, I'm a 2 in my mind, but if you give me Google, I'm like a 4.5. So it's like so much of our job is like really good Googling and Stack Overflow.
So basically, you need to have a basic, at least qualitative understanding of mathematical concepts. That's a must, that's for sure. But if you can't solve gradient descent by hand, just don't worry about it.
Yeah, I mean, the highest level of math I took, I guess, would be, I did like a Bayesian econometrics course, did not do very well. I just did a project at the end, perfect, because I was the best R programmer in the class, so he was like, oh, well, you clearly are good, even if you don't know math. So that's actually how I got my job now. I went through a classmate in that job, or that class. What was I going to say? I mean, I guess like Calc 2, like, you know, derivatives, integrals, I get that.
Calc 2 was my favorite class in engineering school ever.
Yeah, I don't know Calc. I never did Calc 3. I never did differential equations. I probably can't remember partial integration. Like, I think I could remember the formula if I really had to remember it, but I wouldn't know what to do.
What about linear algebra? Because it's so important when it comes to matrix computations.
Okay, this is where it's funny. So I never did any like real linear algebra until I got a project where I was converting SAS to R, and I was like, okay, SAS documentation is great. R documentation is okay sometimes. I had to like essentially recreate this huge like SAS function for like an ARIMA model. So like not even ARIMA, just like AR1. But I had to like replicate a SAS function all entirely in R, all custom. And I was looking at the SAS documentation, and it gets into the linear algebra, and I'm just like, oh man. So I grabbed like the closest PhD I could find, and I was like, you have a PhD, right? And he was like, yeah, I got my PhD from Cambridge, blah, 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 and biostatistical, chemical, physio, whatevers. And I'm like, okay, perfect. And I just like forced him to give me like a 1 hour learning of linear algebra. And it worked. I mean, like I figured out how design matrices work and what it means to transpose them and what it means to have like, you know, an AR1 inside your design matrix and how to do like the variance covariance matrix. So like I learned all that when I had to learn it because I would have never learned it by myself ever. And I forgot most of it. So I think people got to be a little forgiving of themselves. Like it's okay to not know something until you have to know it, and then you could forget it again. I think that's what school taught me.
It's impossible to know everything. You cannot be the entire IT department all combined in one person. It's just.
But having said that, I do want to note that I think a lot of data scientists think that they're going to go work for a giant company, so they expect that they do the modeling and the data engineer puts it in production, or they do the modeling and then like a software developer will put it into the application for them. That's only like the best companies have those kind of splits. Like medium and smaller companies, you have to know a little bit of everything. And I'm not telling you to generalize. I'm just noting it because this year, you're going to see the same 3 or 4 things come up all the time. Why don't data scientists know AWS? Why don't data scientists know SageMaker? How come my data scientist doesn't know like Git? That's actually inexcusable. You should be using GitHub for sure.
Yeah, well, but SageMaker is just a machine learning application of the Amazon Web Services.
Yeah, it's like an AutoML thing. But even then, there's like people expect data scientists to understand like, you know, data science in any context. So like it's really important to have your skills in a lot of context. So getting an AWS or Azure certificate, knowing about, you know, Git and knowing about like Docker, knowing about Kubernetes, like just knowing about this stuff and even having like done them once or twice, so that when you get forced like me, like, hey Carlos, here's a virtual machine, use only Unix to do all of your Docker setup, and I'm like, oh my god, I know barely anything about Docker. I know barely anything about Unix or Linux or like, CentOS or Red Hat. Like, you know what I mean? Like, it's good to just know a few sentences about a lot of technologies, even if you don't go all the way in and learn those technologies. It's important to know enough about them to where you can Google them.
Of course, it's important to know what questions to ask.
Yep, exactly.
Wow. Yeah, I was wondering, I heard database in R just comes out so much more robust than it does in Python. So would you agree with the statement?
So I think what people get that from is Grammar of Graphics, which is the ggplot2 package, and it's also a book. It's like the theory of graphics. So the idea behind the theory is that you have a pane, so it could be 2 or 3 or whatever dimensions. So you can imagine like a regular XY axis. And then you have geometries and aesthetics. And this is the exact language that ggplot2 uses in R. And aesthetics are mapped to your like pane. And then geometries have these aesthetics. So I know that sounds kind of aloof right now, but just as an example, you want to plot, miles per gallon. You want to plot like weight on the x-axis and miles per gallon on the y-axis, right? That's 2 dimensions. Mm-hmm. So that's your data. Your data is the MPG and the weight. But then you have these aesthetics, and your aesthetics is, well, I want my aesthetic to be that there's a point at the intersection of these two things. As opposed to having a polygon, for example, or as opposed to having lines, for example, or as opposed to having some model output, like a smooth of these like relationships. So you have like your geometry, which is a point, and they have an aesthetic. The aesthetic would be, their color. So like you could color them by something else too. So you could have like the size aesthetic, size them by weight. You could have a color aesthetics, color them by the number of cylinders. And overall, like this grammar of, you have your data, you have your aesthetics, you map your aesthetics and your data have geometries. These geometries are represented on like this plane. When you break down graphics to like these grammar levels, it lets you do it lets you comprehend it a lot easier. So you can start doing funny things like, violin plots and like box and whiskers plots. And you can understand how you would have some functional output of your points of your data, and that would be its own shape or geometry or aesthetic. So yeah, a lot of really interesting ideas there in just terms of like how there is a grammar to visualization. And ggplot2 is like one of the best, it's like the biggest package in R for that. Otherwise, Plotly is really well known. Plotly is a JavaScript API that you can access in Python or R, and I think Scala too even.
And ggplot, even I heard of the ggplot, although I didn't even write in R.
Yeah.
It's a popular package.
Yeah, ggplot is popular, and then Plotly is really good because they're interactive. So Plotly is an API that lets you spit out like HTML-enabled plots, so you can drag, you can zoom in, you can zoom out, reset, share, download as a PNG, have a hover, so it has like tooltips you can hover over. And technically, ggplot2 also has that because ggplot2 will record where your mouse is, and you can like click and record coordinates. But yeah, a lot of really cool stuff graphics-wise in R. And I think R Shiny specifically, I'm going to shout out again Matt Dancho's course on R Shiny. He actually has this new learning labs he's doing on like R for Excel users, and he talks about how R can do pivot tables, and it can do VLOOKUPs and index match and all this stuff that you do in Excel. So yeah, again, I think R is so good for business and making business impact as an individual.
Oh, it's so powerful. So R is good for business and research specifically.
Yeah, and I mean, I think there are production uses where it can be usable, but I definitely understand why people say, well, I'm not going to use Keras inside R. Like, I understand why people think that they're going to use Python for like deep learning. Oh, is YOLO doable in R? I don't know if YOLO is doable in R. I know that the guy who made YOLO is no longer in computer vision because he thinks it's like dangerous, and I agree. I think facial scanning stuff and a lot of computer vision stuff is extremely dangerous. and
Have
we have
you
no
seen those
concept.
deepfake videos? They're terrifying and fascinating at the same time.
Well, that guy in India is using deepfakes to do translation so that he can pitch his political message in multiple languages. India has like dozens of languages, if not more. So he's using deepfakes in a productive way for like translation and videos, but also deepfakes and politics. I'm not sure they should go together. But yeah, no, deepfakes is terrifying. I don't know enough about the YOLO algorithm to actually say whether or not it can be done in R. I assume that, like everything else, it's data constrained with a loss function and like some second derivative being minimized. So I imagine, as far as it's an algorithm, I'm sure someone has tried it in R, but I wouldn't know.
It is executable in one form or another.
Yeah. RAM. That's oh my gosh, the most important things for R. R uses a lot of RAM. It stores things in RAM. So what does that mean? It means that sometimes you have to involve other technologies to do giant data because you don't want to do everything in your RAM if your RAM's not huge. There are things like SparkR that exist to do that stuff. Otherwise, what I recommend to people is sample your data and really make sure that you have like what you're going to do to all your data planned out. And what things you can do are you can do smaller sampling, and then you can use packages like Profvis, Profvis, which is I think also a JavaScript package that they have a wrapper for in R. And what it does is spits out every like line of your code that does something. It tells you how memory allocation changes, and then it also tells you the amount of time that operation took in microseconds. So there are like some really interesting things that I've done where I'm just like, oh, like this app is taking forever. Let me Profvis the entire Shiny application. Let me go through the application once, and then I get a giant Profvis out of it. And then I can say like, oh, I've noticed that rendering this table takes a lot of time. I noticed that this lapply takes a lot of memory. I noticed that this split takes a lot of memory. And it has like a full trace back to all these like functions and how they're layered. So Profvis is insane. Definitely use that. Just use Profvis, especially for speed testing.
Yeah. So you just need it because it's RAM based. So it means you would need like some additional hardware to fall back on to take the load off of the computation.
Yeah, I think so. R runs in like we have R instances. So you have RStudio open. You can open RStudio again. You have two R instances open. So there's like instances and there's like total RAM. And sometimes there's a little bit of RAM fear mongering because unused RAM is RAM wasted. They say that in computer science. I don't know that. I don't know much about that, but they say that. So then it's not just about RAM. It's also like how many things are working in parallel. And there's always like programming things you can do. You can use like promises, use asynchronous programming to like manage how much like computer resources using depending on what's going on. But yeah, I would just say there are a lot of resources out there to like learn how to use SparkR and how to do like multi-processes and open up your laptop more to do parallel processing. Really useful for like random forest modeling, which uses a lot of RAM. I think if you parallelize random forest, it's like 10x faster than just using one core and like one R instance.
Yeah, and
functional
R is
programming.
really good for parallel computing.
Yeah, some of these things I think we're definitely walking into the territory where maybe Python as used is better because people who learn Python learn it for a reason and they get put in these environments where these skills are more important. So they like develop these skills and they like those people become representative of Python because they like do a lot of specific things in Python. So I'm not sure. Like, I don't want to say. I really try not to say that anything's better than the other. I like R for my reasons, but functional programming, I'm gonna specifically call out because I think functional programming is so good, and I don't do object-oriented programming ever. I never do it. Never make objects. Never save methods to them. I never do that. So huge proponent of functional programming. I think it's easier to think about. I think it's easier to debug. I think every Shiny app should work like a package. Use packages like Golem to help you. They talked about that at our RStudio conference. This French firm created Golem for their production level Shiny apps. So functional programming is super good. Use Roxygen 2. Use those templates. It's in RStudio, really easy. A lot of these are just kind of Google. You just have to Google Roxygen 2 and
functional
Golem.
programming data is immutable.
Yeah, I don't know. So you're hitting the limits of my understanding. I know what a mutable is, and I know about like prototypical stuff or something like that. And I know a little bit about like why you do certain things in object-oriented programming and why it's useful sometimes. Like I do like inheritance. I understand why inheritance is really useful in object-oriented programming,
Mm-hmm.
but I've not encountered situations where I've needed to do that.
Yeah, because I think in object-oriented programming, the order of execution matters, while in functional programming, the statements can be executed in any order.
Yeah, it's just inputs and outputs, so it doesn't matter. Yes, I mean, I try to use functional programming for everything. Everything I do is in functions, pretty much.
Mm-hmm. So you can basically survive without almost ever touching the object-oriented programming.
Yeah. Other things that you gotta learn. Version control. I know I mentioned Git, but version control is super important. And not just even version controlling. I think people think of version control in terms of like, oh, I need to version my code. That way, if I make a mistake or change my code, I can go back. That's like the level 1 reason to use Git and do version control. The level 2
That's
reason,
branching.
yeah, the branching, the check-ins, and all that stuff, the commits. The level 2 reason of version control is that ultimately you can't get away with things like, oh, it works on my machine. Like, it's not okay. Like, you can't, like, just because it works on your machine doesn't mean it's going to work on someone else's machine. So you got to learn to
Because
like
otherwise
version everything.
it would feel like a developer just threw his or her code over the wall. But
Yeah, exactly.
The thing is, there should be no wall. It should work across different machines and different platforms, and for that, the code needs to be polished and tested in many different locations, and that's where version control comes into play.
That and like I said with Docker too, it's like, you know, there's a lot under the hood of R or Python, and not even just like the C, but I mean even like the binary, like the 1001 stuff. There's so much under the hood, and any of that could break just like at any time on any computer. So you have to do things like, versioning your packages. Like, when I submit applications to my clients, I list every package and its version, and I have I have like multiple mechanisms for getting these packages onto a machine. So like you can use MRAN, which is Microsoft's CRAN. It has like specific dates for every day they copy all of CRAN. So you can do it that way. You can do PackRat, which is now the outdated version of RM, so R environment, RENV. So you can like version your packages. You can do Docker, of course, for containerizing and make a Linux virtual machine and just throw on like CentOS 7 or Ubuntu or whatever. I don't know much about that stuff, but you can throw on these things and then you can put them in a container. And then the idea being like anything that runs inside this container will always output the same thing because everything is the exact same.
Yeah, because
it's the same operating system.
When it comes to containerization, you just ship your code more effectively.
Yes, exactly. So yeah, I mean, I think that's the next big technology. I said that earlier too. I think Docker is like the next, like Git's already like technology that we're expected to know in data science. I think Docker is like the next technology that we're going to be expected to know in data science. And I would be shocked if in a year job postings didn't say Docker the way they say Python and R. And if they don't say Docker, they'll say Kubernetes or something instead, but still.
Yeah, it's just different tools. I mean, different brands of the tools, but same concept.
Yeah, but Docker's great. I'm not very good at it yet, but it's very interesting. Everything I've read and I've tried so far.
Yeah, I've been reading about containers quite a bit, but I don't have a firm grasp of those concepts just yet.
Okay, I know it's 1:45. I think I gotta hop off. I'm borrowing a room too long, but thank you again for all of this. I'm very excited for all the snippets and for this to come out.
Thank you so much.
Where are you gonna post this stuff?